All right, so today we're going to be talking about representation of functions. And functions is a word that we use to describe a mathematical operation done to a number that gives you a new number. And we've done that many times with plugging in x values and getting our y values. So technically that's a function, right? Something's happening to that number that produces a new value. And what we do is we call those function rules. And what a function rule is, it's an equation. And it describes the relationship between your input, your x coordinate, and your output, your y coordinate. Sometimes you can look at your x coordinate and then kind of predict, oh, I know what they did to the x, that's how they got the y. And more formally, we see it as an equation. So let's write that down. It's an equation that describes the relationship between inputs and outputs. And like I said, sometimes we can already see in a t-table what happened to the x that produced the y. But it's going to be the equation that makes that happen. And because it's a function rule, we're going to think of this kind of like a machine. It's a machine. So here's my little machine. And the rule would be inside. Let's say the rule is y equals 3x. And what you do is you have an input. Let's say we put in a -2, and then out of this 2 over here, out comes a -6. So a function rule or a function has a function, like a machine. It functions, it works, it does something. So mathematically, you can think of a function as a machine that allows you to input one value, something happens to it, a rule is applied, and then out comes a new value, which is -6. And more specifically, in this machine, it only has one output. This machine will never have two numbers or two different values coming out. One goes in, one comes out. All right, so let's look at the first example. And example 1 says to write the function rule. And by that, it means they want us to write the equation for the following sentence. The rule is the output is 5 less than the input. Okay, so that's our phrase. The output is 5 less than the input. Now let's remember that the output is our y coordinate, or our y value, and the input is considered our x coordinate, or our x value. Because in any equation, it's always the x coordinate that gets plugged in, and then after the math is done and calculated, your output is your y. So we're going to understand this output is going to be my y. And it's telling me that the output is, so y is 5 less than the input. So that means we're taking our input, which is our x, and we are taking 5 less than that. And so that is the rule given this phrase. The sentence becomes this equation. Now, to further explain why less than was written this way, most students will put 5 first, subtraction, and then the x. But if you really think about what this really means, it's 5 less than an amount. So if I tell you that you have $5 less than me. So what that means is, if I have $25 and you have 5 less than me, you have 20. If I have $15 and you have 5 less than me, then you have 10. So if I ask you, how much do you have? Your question would be, well, how much do you have? Right? You have to say, well, how much do you have, Miss Flores? Because if I have 5 less than you, let me know how much you have, and then I'll just subtract 5. So that's where this concept comes from. 5 less than what? You need to know that initial number that they're referring to, then you can subtract 5. So that's why mathematically we write it this way, because it just makes sense in the calculation. All right, so let's look at B. B says, the output is the square of the input. Okay, so the output is the square of the input. And if you're not sure what a square means, it's like second power. So it could have also said the output is the input to the second power. So just so that you know, those two are synonymous. So again, the output, which we know as y, is, that will be our equal sign, the square of the input. So we take our input, which we call x, and square it. Right? You've seen the terms inches squared, feet squared. It means a little 2, which means to the second power. So that's just the short notation is putting the little 2 in that exponent. So the rule ends up being you're taking your input to the second power, and there you go. That's what square means. And so the next example is I'm giving you a function, and we're going to practice putting in some inputs and calculating some outputs. Example 2. Given the function y equals 2x plus 5, if the input is 3, what is the output? Now, we've done this before. We've had equations, we've plugged in x's, and we found y's as we're completing a table of values. So this is really nothing different, except now instead of just giving an equation, we understand that it's a function, and for every input, you will be getting an output. So it's just more practice of the same thing we've done before. So what you do is you do what I like to call a plug-in bubble. So y equals 2. That's going to be the spot for my input. It's mainly just an example to practice new vocabulary with things we already know. All right, so the input is 3. That would be my x coordinate, so I'm putting a 3 in there. And when you do the math, y equals 2x, 2x plus 5 becomes y equals 2 times 3 plus 5. And 2 times 3 is 6 plus 5. And that gives you 11. So that means what is the output? The output is 11. And we know that also equals the y. So your output, or your y, is 11. Okay? Next example. So this one, I'm going to give you a little reminder. let's make a note of something. A function of the form y equals mx plus b is a straight line when graphed. So, because we've graphed things before, when you see your function or the rule given to you ends up in this form, you can already kind of predict that it's going to be a straight line because you've seen this before. So, example 3. Oops. Graph the function y equals negative 2x plus 1. Now, we've done problems just like this before. The only wordage was different. Graph y equals negative 2x plus 1. Now they're throwing in the word the function. Again, it's just so that you understand that it actually has a purpose, that this actually does something. It takes numbers and converts them to other numbers. So we've known that already. We've done t-tables with that. So that's what we're going to have to do here. So instead of calling it the x and y table, it's our input-output table. And again, this example is just solely to use new vocabulary. Nothing that we're doing is actually any different. Input's negative 1, 0, 1. And we'll go ahead and use our formula. So, negative 1. If I plug in a negative 1, I'll do it over here. So we have negative 2 times negative 1 plus 1. And that equals 2 plus 1 is 3. And then for our next one, negative 2 times 0 plus 1. That's 0 plus 1, 1. This is like me applying the rule to these values. Negative 2 times 1 plus 1. It's negative 2 plus 1 gives me negative 1. So these inputs produced these outputs using this function. So now if I want to also add my coordinates, you understand this is your input with that output. 0, 1 is my second one, and 1, negative 1 is my third one. And then again, you would just put them on the graph. Negative 1, 3, 0, 1, and 1, negative 1. And then your line does this. So again, nothing different. Just instead of x's, we now have inputs. Instead of outputs, we now have instead of y's, now we have our output. And instead of just seeing it as an equation, we now call it a function because we understand that it has a function. It does something. It changes our values into, our inputs into outputs. There you go. So it's nothing new. Just know that your linear equations are functions, and just focus in thinking of an equation as a machine that converts one number into another. There you go.